All right, I think we can get started now. Good morning, good afternoon, everyone. I'm Kundan Vyas. I'm a part of the product team here at Stream Native. I also focus on the partnership strategy. It's an exciting day today because we have a special guest, Ben Gamble from Viverka. So, Ben, how are you doing?
Hi, Kundan. Great to be on the call with you at this late hour on my side, early on yours. It's been quite a pleasant, if cold, November day. So hi, I'm Ben Gamble, Field CTO of America, the original creators of Apache Flink. It's great to be here with you.
Awesome, awesome. This is great. I'm super excited. I'm glad we have Ben with us today. So I know we have a few different topics we want to go over today, but I would say the main part of the session will be focused around three sort of main challenges which most enterprises face as they're setting up a data streaming platform and trying to get successful with it, right? So I think, and then we'll also share some solutions for you to explore. Yeah, so I'm super excited to kind of partner with Ben to chat about this today. But just for the benefit of the folks who are not familiar with Stream Native, I thought I'll quickly cover some background about the company. So Stream Native is created by the founders of Apache Pulsar as a technology that was created back in 2012 in Yahoo. Supports both streaming and messaging, and that was open sourced as a part of the Apache Software Foundation. And it went through the life cycle, made its way to the top level, being a top level project. And then in 2019, Stream Native was formed and has been committed to offer fully managed services in the cloud for Apache Pulsar. So this was a really very great period for Stream Native, a lot of growth for the Apache Pulsar community and Stream Native as well. But then earlier this year in 2024, we also launched our support for Kafka through our Kafka compatibility API. For all the great work which was done on the Apache Pulsar side, we felt the need that there was an opportunity for us to roll out these great capabilities to the broader Kafka community as well. So hence we offered basically rolled out our support for Kafka through a Kafka compatible API, right? So that's a little bit of background about the company. If you think about Stream Native, of course, we are the Pulsar company, but now we are also a Kafka company.
It's been
Uh,
quite fun to watch as someone on the sidelines, as someone who has both used and sold Kafka in the past. It's kind of amazing to
Absolutely.
see the kind of unification in the middle of all these different protocols.
Exactly. As we sort of solve some of these problems, it's an interesting pattern to see how we can, hey, some of these problems can be rolled out to this broader community too. So some of those observations, you never know how they impact and help the other community. So we are super excited to roll out this support for Kafka as well through Streamlabs. So absolutely. So I'm going to quickly cover a little bit about our core platform from the Stream Native side. Right in the middle of Stream Native, at the core of the Stream Native, we offer support for Pulsar and Kafka. And then we offer connectivity through various connectors, both built on Pulsar IO and Kafka Connect framework. With the support for Kafka Connect recently launched, now that opens up really a bigger ecosystem of connectors for our customers and even partners to kind of leverage and build more on. Essentially, this would be a bigger portfolio of connectors now available for our customers to use to build connectivity with their systems. We also have various SDKs for both Pulsar and Kafka, which can be leveraged to write custom code, like for your producers and consumers, which can interact with the core Stream Native platform. Lakehouse storage support has been there. I think we rolled this out way back into 2023 as a private preview. This year, we'll launch this as a public preview. And I think we essentially natively support the ability to offload your data in some of these open lakehouse formats like Delta Lake and Iceberg. So we're pretty excited about that vision, which we're working on, right? In terms of the processing engines, we support a whole bunch through different types of integrations and connectors, but I think the core part of today's session is going to focus a lot more on managed Flink, which is powered via Viverka, and that's what we are here to talk about, right? We also have Pulsar functions, which are a lightweight way to process your data using your own business logic written in different language runtimes like Java, Python, and more. So that's built in within Stream Native Cloud. And then our support for different types of protocols, including Kafka, which gives us the ability to be Kafka compatible as well. So that's a quick summary of our core platform, right? Now, I want to get a little bit into some of the background around our conversation today and what is leading some of these majority of the companies to kind of like primarily focus on real-time data and the need of the R, right? So if you think really about any company, any business which needs access to data in real time, they will absolutely need data streaming and data stream processing platforms to like get insights into your data. So I'm just going to pick one or two examples to start with, right? Think about monitoring and alerting. Every company, every industry, any vertical, every company is becoming a software company because the involvement of software in any company to basically drive either their business analytics or getting insights into their data as their customers and partners and employees are having these conversations is critical, right? So like, imagine you're deploying software and getting alerts few hours later about something which is failing, right? And imagine the reaction from your customers. They're going to be really upset to if you break your SLAs. So I think the need of being notified immediately as and when something is breaking through alerts is critical. One more example quickly. Imagine a world where you're not notified in time about a fraud happening with your bank account. Someone's logged into your bank account. It's almost like every banking division, every financial institution, it's no longer a luxury to have a feature like fraud detection. It's more of a need of the hour so that they can notify their customers very quickly about things happening in real time, right? So Ben, any thoughts from your end about, what are some of the use cases you're seeing? Any insights based on your conversations?
Yeah. So happy to kind of chime in on this one because it all comes back to a couple of very important things, which is tell me a time your customer asks for data to be slower, and I'll be surprised. Like everything from the advent of the internet onwards has basically been this continuous march of can we have it faster now? From when you used to get your statement mailed to you in the post, to when you used to get an email, to when now you check it online, to now your payments come as push notifications to see if they were accepted or rejected. This kind of move towards the now, not even just real time, but now as the answer to every problem means there's not very many options but to just have current data. Now, if you all remember way back, and if probably some of you all are older than me as well, where your credit card used to go on that carbon paper and they pushed backwards and forwards quickly to get a carbon paper copy of your card details, which they'd then mail to a bank to get checked. Credit card fraud in that day and age must have been rife, to be honest, because you got your
So
statement back a month later, you paid a month after that, and then hoped you weren't kind of caught out. And we work a lot with banks and card processing companies specifically for this ability, and we rely on the fact that there is already data moving through a system, as everything is technically an event already. So it's why aren't we using the tools for these specific things? There's kind of this convergence that happened a little while ago where everything started to feel like a microservice. And then over time, we suddenly realized that actually microservices are just one way to do it. There are now event pipes that can connect to microservices or event stream processors that goes directly with those events where they are. And that's kind of the pattern. It is and the last line here is really what it comes down to, that customer experience enhancement. Why do you need real-time analytics? So you can sell the right thing at the right time. Why do you need monitoring alerting? So your customers don't experience downtime. And why do you need fraud detection? Because no one likes their stuff being stolen. And it all comes back to that customer experience for me.
totally, absolutely. And I imagine the state of the banks and having to deal with the frauds. I don't know how they even dealt with that. So
I know
now
it's fascinating. I kind of want to have a kind of a banker of yesteryear online just to talk about what was fraud about. I get the impression the only reason it didn't happen was because you had to go, you went into your account branch and they looked you in the eye and said, "You sound like a trustworthy person."
true, but now they can rely more on the cooler technologies like data stream processing. as long as, of course, they have you learned how to use it right, and that's what we're here to chat about.
Mm.
Cool. So that's great. So let's move forward a little more. So right in that context of the importance of having access to your data in real time. Um, um, Definitely want to talk about a managed Flink service from Stream Native in case the customers or the attendees on the call who have not heard about this announcement. We announced a managed Flink service for within Stream Native Cloud last month, and this is really our collaboration with Verberica. We wanted to take advantage of all the awesome things Verberica has done over time, and particularly they being the creators of Apache Flink. There's no better way to partner with somebody who is the creator and understands the technology best than anyone else. So hence we decided to come up with this service which could benefit our common customers in terms of helping them with their stream processing needs, right? So now I think I'd like Ben to share a little bit about the program which is powering this capability within Stream Native and their thoughts behind that. Yeah.
Sure thing. So, like, Stream Native was the inaugural partner for our Powered by Verica program. The kind of goal of this was to try and bring the kind of the cloud. So at Verica, we were the original. Verica was founded by the original creators of Apache Flink some 10 years ago. We kind of had our 10-year celebration in Berlin a few weeks back with CG, one of the founders of Stream Native, on stage with us talking about this. And then the next week, we're at the Data Streaming Summit talking about it again. For us, this is really important because data doesn't live in a vacuum, right? And Flink definitely doesn't. Although you can just use Flink on files and such, that's not as much fun as using it with data streaming technologies. And particularly with what Stream Native have built with this truly flexible, truly scalable, and very adaptive layer that converts protocols at will, it kind of felt like a really good partnership. And particularly with the Powered by program is the ability to have that there and then. Data needs to often live where processing lives. And particularly these days where costs never go down, it's nice to actually have something co-located so you can actually cope with it. And it was a really natural fit to be able to add these systems together for us. And a kind of a big thing about what Verica brings is enterprise grade performance and capabilities to Apache Flink. Now, Apache Flink is used by some of the largest organizations on the planet, from your Netflixes, your Apples, and your Ubers to some of the kind of more hardcore banks use it for their fraud and risk detection. But what we are here to do is give you that with more. We run single clusters with 35,000 jobs or more. You have clusters that process more than 10 petabytes a day, over 2 million cores, and almost 7 billion events per second on a single cluster. These numbers are possible due to a lot of hard work. It's taking that 10 years of open source innovation and providing a bit of a cloud native revolution on top, which we'll talk a bit more about later. And combining that with Stream Native is kind of gives you kind of this special power to scale to meet any need.
Cool. That was helpful, Ben. Thank you. So just to add a little more on, again, the managed service within Stream Native Cloud, essentially as a customer of Stream Native Cloud, as you log in, you can get a Flink environment up and running in a matter of seconds, right? It's almost just literally available. And then while you can deploy your Flink applications through Flink deployments, while the Flink is running on Stream Native Cloud infrastructure, it is powered, as Ben mentioned, by the Verberica's engine, and he's going to share more details about that. So this is definitely an example of a true collaboration between two companies who align on a goal and a vision to really cater to our common customers. And also, like, taking advantage of this, our vision here is also to see how we can, continue to take leverage Verberica's innovations in the Flink side within and directly within Stream Native Cloud. So I'm super excited about this service and this partnership. So let's move forward. So today we want to actually focus a little more about some of the challenges when it comes to most of the enterprises which face related to setting up this platform and being successful with it, right? I think we covered a few use cases which are critical for some of the large enterprises to be successful today. Again, as we mentioned, access to data in real time is no longer a luxury, it's a need of the hour. But as you start on that journey of setting up your infrastructure to get access to data in real time, there are a lot of challenges which particularly large enterprises face, right? This could this could vary from different areas all the way. Imagine a larger company. Just picture this where you are a bank or you are a e-commerce company, generating petabytes of data per day, right? And now your bigger focus should primarily be in getting access to that data in real time quickly, and then, providing visibility even to your customers wherever they need to, rather than focusing and spending all your time and the platform and all the infrastructure around that. So there are various things which lead to these different types of challenges, and some of them being the massive amounts of data which is growing very quickly, and of course the massive costs related to infrastructure as well, right? As we get into this, Ben, I don't know if there was anything you wanted to set as a foundation or a background to some of these challenges which typically
Yeah.
large enterprises are facing.
So the thing to always note here is we say large enterprises because they're the ones who are normally screaming about it. It doesn't mean these issues don't exist at a small scale either.
True.
And even at a large company, these problems nearly always start off small and then spiral out of control. There are very few small companies I know who don't plan to be a large company at some point soon. And it also means that like setting yourselves up for success and being sure that you've, started with a good foundation when it comes to data practices is often a really good way to get there faster and not then have to do a massive re-architecture. There's kind of a running joke around the enterprise architectural changes, which are, an enterprise migration, 1 year in the planning, 3 years in implementation, and 5 years into a 3-year plan when it comes to delivery. This happens because of this exact thing where, with the best of intentions, people have set out to do the really hard bit, which is I want to do real time software. I want to do strong user experiences, but I didn't start on the right foot. And this is where it always comes from. It's like massive volumes of data only happen when you're succeeding. So be ready for success. Don't fail by succeeding.
True. Absolutely. So with that, actually, let's start with the first challenge which we commonly hear from our customers and most of the enterprises we talk to. While there are many, we're focusing primarily on three today. So the first one's really, uh, if I were to simplify it, two things. One is, setting up Flink, which is really now an established standard when it comes to stream processing, right? Um, it's an industry standard. People want to use it. Setting up Flink environments are complex, right? That's number one. So imagine you're a large enterprise. You want to get a Flink environment up and running and wire that up to where your data is, and then do some meaningful processing of your data and get insight to it. Doing a POC around that sometimes can take weeks up to months, right? So that's a first problem where people are looking for a quick way to get started with Flink. That was the first issue we've come across. And then the second one really is, as enterprises are successful with setting up the environments, very quickly you realize that there are, these two different, I would say, networks where essentially your Flink environment, which is the processing engine, and where your data, which is getting produced from all your sources, are living. And there's a thick line of network which is separating them, hence, driving all the network infrastructure costs, or other cross data transfer costs, right? So we've heard this many times from our customers. So one of the steps we've taken here essentially is to, first of all, yes, make this service available out of the box within Stream Native Cloud. So you log into Stream Native Cloud, and in a matter of seconds, you have a managed Flink environment ready for you. And you can you can deploy your applications very quickly, right? But the second most important thing here to help with the networking infrastructure and the setup is really that we've ensured that we've brought your processing engine literally next to where your data is, within the same network, within the same VPC. Now, like, keeping that goal right from beginning has helped us give confidence to our customers that they can certainly avoid, like, they don't have to be up in the night worrying about these network costs which are happening between your data and your processing. So like packaging that within the same VPC definitely helped a lot of our customers. At least we've started getting a lot of good input on that,
Yeah.
where they can sleep well in the night about that. So Ben, anything you want to add there?
Yeah. So just
Yeah.
gonna double down on that one actually, because like cross-region traffic, you've probably seen some of the blogs out there in recent times on everything from Hacker News to Reddit, where it's like cross-region traffic is the number one cost of a lot of your clusters. And particularly now, if you're then having to launch multiple VPCs, even with the best cloud architecture in the world, you're still spending money. And this is the kind of not even the fact that most of the most complicated workloads, the dirty secret is they live on-prem. They live on custom metal. They live in Bastion outpost servers, even if they're on AWS, because it's not that you can't necessarily trust your workloads to the cloud, it's that you're not allowed to sometimes. So comes down to the idea of where, like, the closer you can package this stuff, the smaller your surface, the smaller from both an attack perspective, from just your isolation perspective, and the number of audits you've got to do. If you've ever had to do a master service agreement with a vendor, you'll know you don't want to do more than one. And I know this is kind of like a maybe this is mostly my prejudice showing, but they're long and complicated, and the legal hurdles your team has to deal with are often one of the biggest impediments to actually getting the answers you need. So the ability to have this packaged in one place, so that without risk you can get the answers you need, without risk of like and more, they're bringing in a million different vendors. We wanted to give you those answers in one place. So this is co-located in the same Kubernetes cluster. If it's on your metal or in our thing, in whatever AZs you need it to be in, we can just put it in one place. Now, this is not to say we're not going to be resilient, we will, but resiliency is a cost trade-off, and we want to give you the opportunity to dial that dial to where it needs to be.
Exactly. Yeah, totally. So network definitely one of the biggest problems, and hopefully our customers can explore the solution here. So I wanted to actually chat a little more about the approach we have taken to kind of address this so that our customers understand a little more about that. So we had to actually, take an approach to re-architect our cloud infrastructure here. So just to give you a little bit of sense of like we have the control plane, which is really responsible for provisioning some of the core infrastructure services using EKS and other things, right? And then we have the data plane where all the resources are getting provisioned. So first of all, I think all the tools which we use for actually interaction between control plane and data plane, they're all open source tools, like and then things like Terraform or even the APIs which are used primarily for provisioning resources on the data plane are all open APIs like Kubernetes APIs and things like that, right? So if people want to actually do any of the audits about how these interactions are happening, I think it's much more transparent and easier for customers to do ever. But we introduced this concept called portable data plane. Now, essentially, the higher level thought here is that with the idea of partnering closely with companies like Verberica here, particularly for the value they bring in through their Flink engine, we wanted to be more flexible about how we can, easily plug in a compute from their end, right? So essentially, our bring your own cloud environment is can enhance to support the flexibility which it needs to plug in a engine very quickly from one of our partners. So in this case, this is pretty much what we've done, essentially re-architected this so that it's a little more loosely coupled, easily pluggable for a third, like, a partner service. And that definitely gives us the confidence that in the future, we continue to focus on collaborating with Verberica to bring in these innovations very quickly rather than worrying too much about how some of these things will work together as a packaged, solution within the cloud, right? So that's definitely the vision around that. So I think we'll share more on this as we go along, but essentially the portable data plane is the term that we call, and that's giving us that flexibility to kind of bring compute engine from our partners and easily plug them into a bring your own cloud environment. Now, again, of course, to come back to some of the key things around the value which that brings for our customers, one of that being one of the most valuable things which our customers can get out of this is really the reduced cost around the network, because I think you're bringing network also closer to essentially the data is closer to the processing engine. and various other options around like how you can flexibly deploy things, right? So that's a little bit on the first challenge related to complex setup and the networking costs. And with our portable data plane, we are now able to kind of offer some solution for our customers to be able to reduce the costs and also get started very quickly, right? Moving right along to the second challenge. So again, we are talking about a journey of an enterprise who saw value in building a real-time data platform, got started with it. And then again, just going back to the core situation with most companies, any company would want to focus more on getting, value out of the data which they're producing on a daily basis rather than worrying too much about the platform and the performance. Now, one of the challenges definitely has been with most companies where while they are sold on the idea of using Flink, it's very hard to like get that deep expertise in figuring out how to performance tune your deployments so that they can give you the results or the latency based on the SLAs you've planned for, right? So what we've done here is essentially, again, we are continuing to leverage the best of the engines here for Flink, which is from Verica, alongside Stream Native's Ursa. In case you've not heard about Ursa, I think there are, I'm happy to cover that separately in other sessions. But essentially, that's our core newly launched premium engine, which offers you a lot of value-added capabilities and deployment options to reduce your, infrastructure and data storage costs, right? Now, what we've done is brought together our premium engine, Ursa, along with Vera, which is actually from Verica, to offer a massive performance gain for our customers. Now, customers, without having to worry about performance tuning their Flink applications, they can rely more on all the advancements from Vera, right? So for Vera, let me have Ben tell you a little bit about what are some of the performance gains customers can see as they adopt Vera through Stream Native Cloud. So Ben, anything you can add in
Sure thing.
here
So
would be
let's
really helpful.
just to go into a bit, like the core thing to note here is that these technologies are not new. And by not new, I mean like both of these things have now got a good legacy of things behind them, right? This is not, these aren't fly by night projects. These are, well established pieces of kit which have been running for years in production, doing some of the hardest workloads out there. But what that really comes with is the fact that they've evolved. And where we kind of came to this, both kind of companies and others have also come to the same conclusion, which is that at a certain point, if you step back, you can make a big change for a big win. And like Ursa specifically, I was fascinated about. I managed to corner another one of Stream Native's founders and chatted for 2 hours at an event a little while ago about this exact thing. But it's the Vera comes from the same thing, which is the cloud native revolution came, and there's a lot of things in Flink which are amazing, and part of that is because it's open source. There's so many different innovations have come in, but what that has meant though is some of them have been unfocused. So what we did was we said, let's focus on the ones that make the most difference now, and this is where we come to some of the kind of big changes. So next slide, please. This is where we came to the idea of three main pillars, which is streaming data movement, the ability to ingest data in real time. So this is where Flink CDC came from. We open source this as well, but we have an enterprise Flink CDC engine, which allows you to do things like take a Stream Native cluster and say, give us every topic at once as catalogs, give us every Kafka topic as a catalog entry, give us every MySQL, every Oracle, every DB2 table that exists as a catalog, which will change over time and have that evolution with it, meaning you can move data as you need to. The next thing, of course, is real-time stream processing, that thing Flink is famous for. Now, we have a custom engine in the custom storage engine inside Vera called Gemini, which gives you both tiered storage and faster joins for any kind of reasonable amount of state. The problem with state is it's only going to get bigger. And the more successful you are, the bigger your state is going to be, which leads to this kind of constant problem of you need small local state to be fast and agile and scaling, but you also need to have big state to have value. So we kind of built a tiered storage engine specifically engineered around the demands of Flink. And the last one, of course, is the Streamhouse, where you've all seen the kind of the evolution of everything on S3, and part of what makes Urza magic is that kind of S3 backed focus as well. And on Vera, this comes with by including the another top level Apache project called Paimon. This is a real time open lakehouse format, and we call it the Stream House because it supports streaming. It allows you to stream data in from all those different places and then store and join against it in near real time. Is it as fast as storing it in memory? Gosh, no. But rather than being accurate to hours or days, it is accurate to minutes and seconds, meaning that for when you need to have that terabyte level lookup, you can still do it inside seconds rather than inside hours and join against that in real time. And this is where kind of Vera comes from, to kind of bring that kind of cloud native speciality into the kind of that 10-year legacy of constant evolution in stream processing.
Awesome. Yeah, we're super excited to leverage Vera. We'd love to continue to see what sort of other advancements are coming in, and then so we can bring that to our common customers.
Mm.
Cool. Okay, so let's move on to the third challenge here, which commonly is heard between these enterprises as they're adopting the platform. There is definitely, well, companies are starting to put together data platforms, data streaming platforms. You realize that, they come up with a list of requirements, and then it's really, really hard to find a single vendor which is going to really, support all your needs. And oftentimes you're looking for ways in which, you can sort of leverage the best of breed, from different vendors. But even in that case, what is the integration experience and what is the approach of actually leveraging that as a unified experience? So these all become like set of challenges which companies, as they start adopting the platform, start to realize, right? So that was one thing which we commonly heard from our customers. So with Stream Native and collaborating closely with Reverica, this is one thing we wanted to ensure that the way we offer this experience to our customers is something, even though we want to be very clear about that, the fact that yes, we are powering our Flink engine from Reverica, and of course, give that confidence even to our customers that you're leveraging somebody who has created and of course knows Flink the best. But at the same time, the experience we want to offer to our common customers has to be something more all tied together and unified, something where they can start using that from day one, without having to worry about the integration, right? So I think the unification part and the thinking which is needed to explore the end-to-end journey of a customer and what they need really went a lot into designing this managed Flink service right alongside with Barbarica. So with this one, I would say that there are different types of industries essentially who have different challenges as they explore a data platform, and essentially they're all looking for while they understand that they'll not find all the capabilities in one vendor, they're looking for ways in which they can at least unify them and come up with a solution very quickly. So Ben, anything you want to share about what you're hearing from customers there or enterprises
Yeah.
available? Yeah.
So and this once again, it comes back to that kind of idea of bringing a complete solution, because one of the continuous challenges you meet as someone who's worked in some of these fields, specifically fleet management in my case, long ago, I did a lot of work in logistics, and the continuous problem is that it's great. So you bring in a MQTT broker. Perfect. This lets you talk to all your field devices in real time. Suddenly you know where they all are. But then what do you do with that data? Do you read it a bit here and there? Well, ideally you do a bit more than that because you want to actually take advantage of the fact it's fast. So you build out a streaming storage solution. And let's say you started with a RabbitMQ in my case. Bad times are had by everybody. But then you moved to Kafka, and then it was great for a while until you needed more flexibility. So Pulsar with its compatibility meant that you could just drop in, replace it, and now you have something quite powerful. But then when it came to what to do next, you still ended up in the same problem, which was unless you have the right bits in the right place, you're always going to be limited by that one thing that's going to hold you back. And this is kind of Amdahl's law in scaling when you come to kind of performance engineering, which is you're always held back by whatever's the greatest proportion of your time. So, and it also applies to actual just generic engineering products or projects with the kind of theory of constraint, which is that if you have this wonderful big stream of data, you're now held back by how long it takes you to build a microservice to compute it. So why are and then your adoption of streaming is held up by how fast you can build stream processing applications. So you end up with this continuous little cycle of time going around rather than saying, okay, so we've brought all the streams. Now let's with the stream processor in one place so we can start actually going faster. And this matters because particularly, let's say, once again, let's go to the fraud example, right? There are now regulations and rules and strict legal consequences of not handling a customer complaint or a customer action fast enough. What that means is, unless you have that end-to-end speed, so back to Amdahl's law again of, I can stream it in 300 milliseconds, but I cannot answer the question in under 2 minutes because of my legacy processing engine works in batch. So every 5 minutes, I have a micro batch running, means I might get an answer every 2 minutes if I'm lucky, if I tune it all the way to the ninth. But if I go to a streaming engine, I can do it in under a second because I spend 300 mils here or 300 mils there and another 300 mils to ship it to the end client. It means under a second and I'm good and I might meet regulations. This is where we always come back to it of like you're by not having the two parts and the two parts of the problem in the same place, you're now limited by how well you can build one of the halves. But both in our case and in StreamNative's case, it's like, great, we've got stream processing, where's your streaming layer? Or, hey, great, you've got streaming layer, where's your stream processing? So we're not trying to fill in those, we're trying to give you those, not trying to give you gaps, we're trying to give you a complete circle. Then you're not limited by your resource by sourcing either side, but instead you're also not limited by the performance of either side. And the worst case is healthcare, right? And an example that came from a previous organization I used to work at was you're now trying to enter your insurance details on your ambulance ride over to the hospital to check if the ER is actually in network or not. They ask you 3 questions and you send back 3 answers. Now you hope they're in order because you went yes, no, yes. And one of them was about your insurance broker, one of them was about your allergies, and one of them was about your date of birth. So now you want to make sure that those answers came in the right order because therefore you need the right solution in the right place. And you don't want to have to build that yourself. So these are the
True.
kind of questions that keep coming around. And it's not, the one of the things Kundan and I have both found is these aren't unique. We both have a chest of war stories of the examples we've seen where all these problems recur.
Absolutely. Yeah. Yeah, particularly the order of the events and so many other challenges which developers really have to focus on to ensure that the insights are going to be accurately shown to the users. So totally. All right. So those are the three main challenges we kind of went over, and then we'll summarize that as well shortly. But I thought I'll just quickly give you all a sneak peek of the roadmap for the Managed Flink service in StreamNative Cloud. Again, in October, we launched a private preview for this service, and it starts with basically support for just Flink deployment at the moment. And it's also only available on Google Cloud. We're going to work towards supporting this on other cloud providers soon. This is really an important phase for us as we can gather some feedback from select few customers and then open it up for open preview or public preview in March 2025. And that's where we want to start supporting the other capabilities from Flink, like Flink SQL and other lifecycle related operations. So public preview we're targeting by March. Hopefully by then we gather a lot of feedback and also roll out some user experience within our console to make it easier for our developers. Our vision here, definitely just like any other capabilities within StreamNative Cloud, is to offer a consistent experience to interact with your Flink service, either you using UI or API or command line interface or Terraform, right? And that's the vision we'll work towards as we go along, building that North Star experience for our managed Flink service, partnering right along with Ververica, right? So I think, yeah, but hopefully by June 2025, as our preview goes fine, We also aim to go GA with it, and at that point, we also want to like aim at supporting Python and other capabilities from Flink. Yeah, so that's a quick sneak peek. And then just to summarize again, I'll add my thoughts. I'll let Ben share his thoughts as well again. But essentially, there are many challenges which any enterprise would go through as they're setting up a data streaming platform. But right now, as we speak now, no, we no longer need that convincing to most enterprises that hey, there is a very much need of the hour for you to have a data platform, data stream platform for your real-time stream processing use cases. Most of the verticals or the industries are very convinced. In fact, they're looking for a more robust solution in that space, right? And in that context, again, some of the challenges from getting started quickly or facing networking related costs or, having these performance issues or even particularly about worrying about the unification between these best of breed solutions. I think we are in the process of thinking through all this journey end to end for our customers and help them out as they, take that journey, right? But anything you want to share as we summarize some of these points
Um,
here?
Mostly it's just about like the general problem with what of a lot of these kind of technologies is they're huge, right? Now, one of the advantages of taking something like the Stream Native offering right now, which has the Blink inside it, is you get the ability to take that through line in one place. And that's saying, like, I need to ingest some data. Brilliant. Here it goes. I have a Python client, a Java client, or hey, even a WebSocket client, and being able to stream that into a Pulsar-based platform at high velocity, almost at any scale. But then it's the ability to say what next. So the classic example right now, the one everyone, of course, has been asked to build is the AI example. So let's take that. So it starts with a chatbot. So you need a way to channel sockets nearly always over the edge. So WebSockets in, put them into a backbone which can scale to any dimension, act upon those messages in real time, via an LLM, making some decisions along the way, and then send them back out. And that is your end-to-end with Pulsar and Flink. The next step, of course, then is you start adding these recall augmented generation pipelines and adding internal processes with data streaming out your databases, doing that kind of CDC approach with the outbox pattern. And the ability to go from the simple to the more complex as you evolve all in one place without having to leave a point of your platform for either scale, performance, or capability is a big win, right? And things like bringing Vera and Ursa together. This is a combination of things. Like you could have always done this with the basically the vanilla open source, but it would have cost you a lot. There are
True.
and performance would have never been quite where you want it to be. Both of these technologies were built around kind of two main axes. One is performance, the other is cost. By going really, really fast, you go quite a long way with less. And that's one of the very few ways to actually get a cost saving these days is to have something faster. So you can use less cores, less machines, because we're not just here to have neither of us report to sales. So we get to try and give you the right thing at the right time. So yeah, it's really about that idea of giving the best pieces of the puzzle in one place, whether it's inside your VPC, whether it's inside your own metal. Like we don't want to compromise along the way.
Totally. Yeah, absolutely. Cool. So that was a quick summary on some of the key points we wanted to cover. Again, for the folks who want to get started with Stream Native, who've never tried their hands on Stream Native, you can sign up for a trial. You don't need a credit card for, signing up and trying out. Once you sign up, you get a $200 free credit. You can scan this barcode to get started. And also, you can go to this link here on the right side if you want to book a demo. And then we'll get on a call and talk to you. All right. And also, if you want to learn more about Apache Pulsar, if you've not already heard about this very popular book from my colleague David, I think please scan for a free copy. It's very detailed and it just walks you through all the, it starts with a very high level and then, of course, covers a lot more internals and details of Pulsar. This is the one book you need to be an expert of Apache Pulsar. So please
I strongly
scan, get your
recommend it.
copy.
It's a good book.
Cool. Awesome. Great.
David
And
writes
then,
excellently.
cool. All right. And then Ben, you want to share something about your upcoming events?
Yes, so Flink Forward was over was looked like it was over a few weeks ago, but particularly if you're anywhere in the Far East over the next few weeks, there is still Flink Forward Shanghai and Flink Forward Jakarta. I'll be in the Jakarta event myself, and to learn more, this is a great opportunity to learn more about both Flink and stream processing processes that go near Flink. Particularly if you're interested in the Jakarta one, please message us, please register. Um, there are limited numbers of tickets for both, and the one in Shanghai is in Mandarin, but the one in Jakarta is in English. So please do have a look and come along if you can. It would be excellent to see you all, particularly for a bit of winter sun.
Absolutely. That's great. Cool. So yeah, thank you so much, Ben. Let's see if there are any questions. And then from any other audiences, let me just check. Cool. Yeah, I think there's I guess one question here a little bit about yeah, I think it's a more common question. What are some of the other um, is there anything you can share about some of the upcoming, advancements or anything from a roadmap perspective or the new cool things you're working on Vera? Anything you want to share on that side, besides what you covered today? People are more excited about that for sure.
Uh, So Vera itself, kind of, as I said, it all comes down on three main things right now. So the big thing I'll state really is that Vera, because of its nature, is a both a hardened and subtly forked version of the open source. So a big thing coming out soon is the Flink 1.20 kind of feature set in Vera, which is kind of a big deal for me at least, because Vera as it stands right now is on 117 and we kind of tend to miss a minor version as we go along because because it just generally you'll find that one, it takes a while to harden any of these things and test any of these things. Hell, there's still a 119 bug on micro batching, which still hasn't been resolved in the open. But also the next thing, well, so yeah, so we always miss a few versions here and there, but also then just like being sure we can offer it as the best service possible. So yeah, for me, the 1.20 release is a big deal, but really it's Flink 2.0 and what's coming with that. There's some major changes and also like a removal of a bunch of the somewhat dead APIs, which we currently have to support, which will make my life a lot easier when they go away. Yes, there are still people doing dataset stuff. I do not recommend.
I see. Awesome. So looking forward to Flink 2.0. That's really cool. Thank you so much, Ben, there. There's one question. It's a little bit about the experience we offer today for private preview in Stream Native for Managed Flink. So the main question is about, what is the main interface through which people can deploy Flink deployment. So yeah, so right now for private preview, we only support a command line experience. We're working on a UI console. So the user experience for doing the same sort of CRUD operations about how package and upload your Flink deployment, and then over time, hopefully a nice Flink SQL experience. All those things are getting planned, a work in progress. But right now, as a developer, you can sort of get your hands on a command line experience to sort of upload your packaged Flink deployment application and then, get that up and running, right? And then, of course, you can monitor your Flink jobs from there. And then um, basically, I missed covering sort of a demos section here, which I initially wanted to, but I'm happy to share that offline through our community. We do have a demo on our Stream Native channel on YouTube, which basically covers this whole experience of deploying a Flink deployment job through the command line experience. And then, yeah, over time, we will add the user experience as well. But in short, to answer your question, it's only a command line experience right now, which you can try in private preview. Yeah. Let me see if
Ooh,
there's
got
anything
another one
else.
here. When would you use pulsar functions versus Flink? Oh, I can take this one. So
Yeah, please.
let's just So just for a bit of background, what is a pulsar function? Pulsar function is a function, normally Java, that runs on a pulsar broker as a kind of serverless effect, right? This allows you something akin to a Kafka Streams or a Flink job, but it's kind of both a bit more limited in scope when it comes to how they operate as of right now. Over time, this is going to change, but they're really brilliant for doing that kind of single message transform type approach. If you think of single message transforms in Kafka Connect, like these are a bit more analogous, that they live inside the topic. They can live inside a topic directly. So they happen broker side, not client side, allowing a lot more power. Why you'd use one of these rather than Flink is simplicity. If you don't have a lot to do with your data, you just want to move it between topics, maybe put them in, like say, if message is above value, put it somewhere else. You know, do a decryption, do an encryption, which is the really brilliant case, by the way. Encryption is kind of the number one, in my opinion, things to do. So partial field encryption, do use a pulsar function. They're amazing for this. They massively simplify your development stack. Now, when you want to use Flink is when you want to reach beyond that. Now, this is partially because you want to have separate resources for streaming and compute sometimes. So any sort of heavy compute where you might actually be doing some serious work, you don't want your broker's CPU time to be churned up doing that. Only because it means you have to scale differently to what you want. You'll end up with a machine spec'd for network churning on CPU rather than doing what it's really there for. So when you start doing bigger scale stuff, Flink is already the better choice. But also, when you want to start doing things which are more external, uh, there's a lot more like tools and primitives inside Flink to do that kind of work. Like there's a full ML package built into Flink. There's a complex event processing framework built into Flink. There's a durable execution framework built into Flink. These things are there in Flink because that's what it's for. In the same way as Flink isn't a streaming transport layer, you can suddenly go between MQTT and Kafka in. It just doesn't have it. In a similar way, it's a specialist solution to the problem. Don't get me wrong, like there is definitely a time and place for both, and particularly the kind of per record or partial record encryption type use case is amazing in Pulsar functions, and I strongly recommend using Pulsar functions because it means you can keep the encryption of your encryption layer inside your streaming layer.
Got it. Cool. Yeah, absolutely. Thank you so much, Ben, for sharing your thoughts on that. I think those are pretty much the core questions we had here. So again, thank you so much, Ben, for being a part of this session. This is super exciting, and I know this is just the beginning. We just launched a preview right now, but I think we are super excited to like embark on this journey with Bavarica at every stage, partnering and exploring the ways in which we can bring value to our customers and simplify their problems, right? So super excited, and thank you so much for being a part of this session.
Thank you very much for having me. And if anyone wants to find me online, I'm just Ben Gamble pretty much everywhere. It's been great to be here and great to chat to you all.
Awesome. Thank you so much. Yeah, bye-bye.
Bye bye.